Hey there, welcome back to the channel. My name's Chris, and today we're going to be continuing working on the Saber Game Embedded project. In the previous video, we talked a lot about the software. I'll put a link to that up here, or wherever it ends up. At any rate, today let's talk about the hardware. Really the next thing I want to do is I want to work on the enclosure. But in order to do the enclosure, I need to have all of the physical pieces at least somewhat assembled. Most important, I need to get that Meadow mounted on a perf board with some screw terminals, so I'm going to go solder that stuff up now. Once I solder everything together, I then start building out the stuff in CAD. Now, the important thing for the CAD drawings really are dimensions and holes for mounting. You don't have to be very specific on everything. For example, you can take a look at this that I have here. It's just a flat green thing with 4 holes. That is actually my perf board. So that is this piece here. Notice this has a whole bunch of perforations and things like that in it. But for my purposes, I don't really care. I just need to know where these corner holes are, where the screws are going to go through. And obviously I need to know length, width, and thickness. So when you have something like that, you can then design, for example, the feather board. Again, you can see that's not very complex. I've got the mounting holes and the size, but then I also have these connectors. Connectors are important because I know that I have to plug the battery in here and I have to plug USB in here, but it also can't interfere with other things. This has some chips on it. I'll just keep that in mind as I'm going. Now, I did measure the distance between here and here, and so that they match what I have in the physical world, but I didn't put all of these other connectors and pins and things on because it just isn't really necessary. So once I have that, then I also know that I have my display. Again, this one's a little bit more complex. I rotate it around here for you. You can see I actually went through and I put the connectors on here. You can see I've got the mounting holes in here, as well as the physical dimensions so that it matches the piece that I have here. And this is roughly where I'm going to put it. I can still move these things around. But the other thing I need to keep in mind is, let's see, I also did a battery. You can see the battery is not all that complex. The important thing, again, is physical size, that it matches what I have here. So then I can put these into the CAD drawing and stack them up and move them around to try to get things working. So once I kind of have them stacked up where I want them, I can then draw a sketch such as this, and then I can go, okay, well, I'm going to project these holes, these mounting holes, down onto that surface, and then I can do things like take this piece and I know I'm going to extrude it up to here, and then I can put a mounting hole in that. So we can extrude those all the way up. And then now I have a mounting piece for this board, and the Meadow is mounted to it. So then if I put some holes in that, I can put in screws. So that is my general process on this. I still have a lot of work left to do on this. Have to do a whole bunch of measurements. There are connectors that need to go in and the buttons from the top and the bottom. But that kind of gives you an idea of how I approach it. I always design the thing that goes into the enclosure first so that I can put it into the drawing, and then I draw the enclosure around those. If you try just drawing the enclosure based on measurements, it never works out for me. Pardon the noise, the printer's running. But generally speaking, what I'll do is once I have an enclosure that I think is fairly close, this one is, the question that I really have is about this fit. Do these holes work? Does everything go together? You can see I've got the buttons on here. I have a couple of these plug sockets they'll go in all of these holes. But you can see, generally speaking, I have it figured out. I actually have a bottom for it as well, but the bottom I'm not at all concerned with. Bottom and top, those are easy. It's this main body, and rather than printing the bottom as part of it, it'll just take longer. So I'm running a test print. So I take this and I just export it to an STL, and then I import this STL into the slicer. You can see it looks fairly good. I did not put any supports on it, so it'll be interesting on these holes if those print out okay. I tried to bevel everything, so these shelves that hold things, they either go all the way to the bottom or they're beveled, that kind of thing. So the general rule here is I put this together, and then, well, it looks like about 5.5 hours. We'll run it through the printer. Hopefully, on the first pass, I'll be really, really close. I might have to, typically I end up adjusting the size of the holes for either heat set inserts or for thread size, things like that. I might have to add in some supports. Really, this first print is just to see how close I can get. My luck is I'm never right the very first time. So we'll do this. Once I print this out, then I can adjust everything and design both a top and a bottom for it, then hopefully print the finals. All right, let's take a look and see how we ended up. Again, I didn't print this with a bottom on it, but the more I think about it, I think I'll build it with a top and a bottom that are separate, and they'll sandwich together and maybe have bolts that run all the way through to hold it together. Well, let's see how the fit worked out. First, I've got this, which is our, perf board and the Meadow, and they're going to go in inverted like this. So the idea is it will sit. You can already see it's not wanting to go in. It's real close. I probably need to take about 1 millimeter off right here. Can see it's intersecting. Let me find something to point with. This will work. So right here, I need to shave a little bit off of right here in order to get it to go in. So there's the first problem. Let's take a look at this. That seems to be lined up just fine. Let's grab a USB, see if I can get it in there. The height of the hole might not be big enough. When it moves forward, I might be able to plug it in. This is a fairly fat connector too, but so I might increase the height of that hole. So of course I didn't think about this. This is why I should model these connectors, but you can see this connector here, the pins come straight out, but they're, pins that, they're obviously soldered in this direction. I could solder on direct down, so the width is fine, but the problem there is I filled in this, which is really a stand for the end of this. That has to get cut out so that the pins can go down through so I can connect a wire to it. Over on this side, we've got our buttons, and just pick a random hole. Oh, that worked. In fact, that works nice enough. Let's take a look if we take the nut off. So that looks really good. Now the question I have here, let's flip it around, is when I push on it, yeah, you can see it flexes right there. It's probably going to be even worse if I go with the middle hole. This will be the reset. So we've got a fair amount of flex, but the perf board will connect from here to here, making this rigid. So I think that's probably good enough. I did a little more thinking on the socket, and this hole actually works really well if I tap it. Don't know why I didn't think of that in the first place. So I've just got a tap here. This is a M6 by 1, so 6 millimeter by 1 thread per mil. Yeah, 6 by 1. If I put that in, the non-chamfered ones actually it fits just fine. But if I run this in, then I can just take this nut, and boy, that just goes in super, super nice and easy. If you've got a soft material and you're trying to thread something into it, if you're concerned about, the tightness of that, what you can do is you can use a helicoil kit or a thread repair kit, make the hole one size bigger, then use the thread repair, run the outer tap in, and then you put in basically it looks a lot like a spring, but it's a set of threads that go in, and then you end up with metal threads into this soft host material, and then you can put this in, so then you have metal thread on metal thread. It holds a whole lot better. So that's it for now. Like I said, I've got to go back to CAD, get some of that work done, make some modifications, and print out another one. While I was in here making these modifications, I did a few other things. So on the bottom, you can see I beveled this. I basically ran a chamfer all the way around the bottom, so it's not square. Did it on the outside edge, because if I had tried to do it on the inside edge, then these flats would have been raised up, and this is the bottom. The idea here is that the bottom piece is a flat piece, but it will have a lip that comes up into that chamfer all the way around. It'll help the bottom lid, I guess, center on it. And then on the top, I did another chamfer, but this one I did on the inside, again for the same reason. That way when I create this faceplate with the hole for the display, it has something that helps it to center. When you're designing these, when you're making modifications based on, interference or things like that, basically you've done a print and you're doing modifications, try to think ahead to next features that you also might need. It helps you with that iteration rather than just changing things and then printing it. Try to change to fix some old stuff and try to add some new features if they don't interfere. Again, this thing takes 5.5, 6 hours to print, so the cycle time is really slow. So the most you can get done in any iteration, try to do that. Well, the first thing I notice is that I screwed up and left the supports on. I didn't want them or need them. It probably won't hurt anything, but I find that supports like that are really hard to get out of these little holes. And they do nothing but get in the way. So now I got to clean that up. It's really stringy, it looks like, too. Maybe I've got something setting with the temperature just a little bit off. Whatever, that can be cleaned up. The important part is we got to check. Oh, let's get that out of there. Now let's check this fit. Oh, man. Should have known better. The boss that I added here is in the way here. You can see, here's that boss I added here and here. And if I show the perf board, cuts right through it. Man, what a stupid mistake. We can take those two, extrude those, and now they're down at the bottom of that perf board.
All right, now I just need to add in the button and print out number 3.
Here's version 3 of the enclosure. We're getting really, really close, and of course I made another one of the fundamental mistakes. I've got this here. If you look over on the design, right in this area, I don't have the connectors, the screw terminals on this perf board, but there are screw terminals on here. And this screw terminal impacts right here. So when I attempt to put this in, so we're looking at it just like we have on the screen, right here hits this. Now I did take the soldering iron and melt a big hole in here just so I could get some fitment testing. And that, with that melted, seems to fit. I'd have a real hard time getting wires into either of these two, so I'll have to reprint it with that cutout. But it at least lets me test the fit. Then the display is going to go on here, but again, I've got to deal with these. I don't want the wires coming off. I'm going to have them going straight down. So I can actually deal with that right here, right now. Then I'll clean that up and solder onto that. But those fit there. You can see when I move the display, it's moving this. So in fact, I need to lift it up just a hair or push this down a little bit. So those are a little too close. So glad I checked that. Got my power switch. It's going to go in right here. I'm not going to push it all the way in because then it'll be a real pain to get back out. But it seems to want to, well, I guess I will push it all the way in. So, power switch seems to be fine. I did forget the piezo and another mistake of not having the hardware sitting in front of me. I forget to include it. Actually, I'm going to have it probably just about like that. So I got to cut out for it. I'll put it in. It can go either way. Got a little space there for the wires, so it fits just fine. It'll take a couple of screws or something like that there. You can see I left an opening here so that when that's in there, the sound can travel across and come out here, so I won't muffle it too much when it's closed. Let's see. That's it. So we'll try version 4. I'm going to cut that down and give more space between the display and the perf board. A couple of minor tweaks and it will be ready to go. Here you can see I've got it fully assembled. See if you can see down in there. So here's the perf board. The Meadow is underneath, so we can plug it in there. It's running on battery right now. The battery is down underneath here. Got my power switch. It does have a piezo here. It's not hooked up in code, but it is at least physically hooked up. And my buttons, I can press. Turns out the downside on these buttons is they're not positive clicks. They don't have, like a reed switcher or something in them. So they're really bouncy. You can see I need to work on the code to make it so if you push it once, you only get one rather than two. Different ones have, different behavior. I've done a little bit of work over here. You can see those are much better than over here. But those work. reset works. This is positive, and then these two are grounded. I did make a mistake, and I didn't have holes for those wires, but I just drilled them out. So the idea here is this would be positive. We've got a connector that would just plug in like that. And then there's a wire that goes to an alligator clip that would hook up on the mask. So it becomes positively charged. And then the blades are connected here. And so when a blade connects to the mask, we get a touch or a touch on that side. So all of that is ready and working. I also printed out a faceplate for this. You can see it's got some alignment pegs, but this slides down right on there. I've got a little bit more code to do. Like I say, I'm going to add sound to it. We can also add some things like maybe a Wi-Fi REST service that would allow you to use a phone to set these, change them. You could even keep track of fencers and scores and a bunch of other things. But for now, this is fully functional. Like I say, I'm going to work a little bit on the debounce of these, but it's ready to go. Thanks for watching.